Good morning, everyone. Myself Ansar Sheikh, Triple E Department, St. Peter's Engineering College. In last lecture, we discussed about incandescent lamps, fluorescent lamps, carbon arc lamp. In this, we are going to discuss about sodium vapor lamp first. Sodium lamp consists of discharge tube made from special heat resistance glasses containing a small amount of metallic sodium, neon gas, and two electrodes. Neon gas is added to start the discharge and to develop enough heat to vaporize sodium. Here inside the glass tube, we are going to place some sodium particles. After that, we are going to add a neon gas so that the sodium will be going to be vaporized. A long tube is required to get more light to reduce the overall dimensions of the lamp. The tube is generally been into a U shape. Working principle of a sodium lamp. An electric discharge lamp requires a high voltage at starting and low voltage during the operation. Whenever after construction we required a high voltage at starting and low voltage during the operation. So at starting a voltage of 450 volts, it is applied across the lamp to start the discharge after 10 to 15 minutes. The voltage falls to 150 volt because of low power factor. To improve the power factor, a capacitor is connected across the supply. The color of light produced is yellowish. This is a sodium vapor lamp. Inside we are going to use a sodium and neon we are going to use. The color of this particular lamp is yellowish. Here this is a pictorial representation of a low pressure sodium vapor lamp. Here we are consisting of an electrodes. Whenever we are giving an AC supply, initially we required a more voltage we need to give. Once the process will be start, we are going to give a less voltage. Here double walled flask will be there with a glass. Inside we are having a tube. In the tube we are going to place some sodium and neon gases. Whatever the why you are going to use, and whenever the electricity we are supplying, the sodium and neon will be going to be heated. The neon will be used to vaporize the sodium. Whenever the sodium will be vaporizes, then we are getting a yellowish color. This is the working principle of a sodium vapor lamp. Mercury vapor lamp. On the basis of pressure inside the discharge tube, the always whenever we are going to using some mercury inside the tube, then we are having some pressure. On the basis of that pressure, the mercury vapor lamps are classified into two types, that is a high pressure mercury vapor lamp and low pressure mercury vapor lamp. High pressure mercury vapor lamps are of the following types. First one is that mercury vapor lamps will be operated at 220 to 250 volts AC main and made into 250 watts and 400 watts. In the second type, these are made in 300 and 500 and is operated at 200 to 250 volt AC as well as an DC. The third one is operated at 200 to 250 volt AC and made in 80 watts and 125 watts. Mercury vapor lamp consists of a hard glass tube enclosed in other bulb of the ordinary glass. The space between two bulbs are completely evacuated to prevent heat loss by convection from inner bulb. The outer bulb absorbs harmful ultraviolet rays. The inner bulb contains argon gas with certain quantity of mercury. In addition, with two electrodes or starting electrode having a high resistance in series also provided. The main electrodes are made of tungsten wire in helical shape. The lamp has screwed cap and connected to supply with choke. A capacitor is connected across the supply to improve the power factor. The working principle of mercury vapor lamp is that whenever the switch is on and full voltage is applied across main and starting electrodes, this voltage breaks down the gap and discharge through argon gas takes place. As the lamp warms up, mercury is vaporized, which increases the vapor pressure. These discharges take the shape of the intense arc. After 5 minutes, the lamp gives full light. It gives a greenish blue color light. This lamp is always suspended vertically, otherwise inner glass tube may be break due to excessive heat. This is a mercury vapor lamp. Here also we are having a mercury vapor lamp. All this fluorescent tube. It is a low pressure mercury vapor lamp. It consists of a glass tube 25 mm in diameter and 0.6 m, 1.2 m and 1.5 m in the length. The tube contains argon gas at low pressure, about 2.5 mm of mercury at the two ends. Two electrodes coated with some electron emissive materials are placed. The color produced by these tubes, if you are using a different material and color, if you are using a zinc, then green color, silicate blue pink, calcium tungsten white, cadmium if you are using bluish, calcium hollow white, phosphate you are using white, magnesium tungsten if you are using bluish white. This is a fluorescent tube. Here we are giving a supply. There you are having an induction coil or choke coil, and then whenever the bimetallic strip it will be going to when it touches, automatically the current will be flowing, and then it will be going to when I run fluorescent tube. A choke is connected in series with the tube, which acts as a blast and provide a high voltage at starting low in the tube. During running condition, the same choke absorbs some supply voltage and remain a voltage of 110 volts across the tube. A capacitor is connected to improve the power factor. The advantages of fluorescent tube is voltage fluctuations has very small effect on light output. The luminous efficiency is more as length of rod is more. It gives light close to natural light. Heat radiations are negligible. The disadvantage of fluorescent tube is its brightness is less, initial cost is more, overall maintenance cost is high. Neon lamp. These lamps are opted at a very low temperature, operated at a very low temperature of about 200 degrees centigrade. That's why these are called cold cathode discharge lamps. The another name for neon lamp is cold cathode discharge lamps. The electrodes are housed at the two ends of the tube, which contains neon gas. The electrodes made of iron or nickel cylinder without any coating, and practically they do not emit electrons. It gives red light whereas with mixture of mercury and argon, it gives bluish green color. Voltage required for starting and operation is 10,000 volts. This high voltage is obtained from transformer. The working principle of neon lamp is when the supply is switched on at primary side of transformer, a voltage of 10,000 volts develops across secondary side which come across two electrodes. At this voltage, discharge occurs in neon gas. Different colors can be obtained by changing the constant, that means a combination of gases and mercury filled with the tubes. These are the neon gas. In the neon gas, we are going to give more amount of voltage. Neon lamp. These are the here we are giving an approximately 10,000 volts we are giving, and the color will be depends upon the gas where are we are going to use. The applications of neon lamps are generally used for advertising. Most of letters having two ends at which electrodes are placed. In letter having more than two ends, the tube path is repeated for some portion. Halogen lamp. It is a special tungsten filament lamp which was developed in 1959. In this lamp, a small amount of halogen vapor is added to the inert gas of the bulb. Its glass bulb is small in size and mechanically strong. It operates at high temperature of 3000 degrees centigrade. This is a halogen lamp. The working principle is that when the supply is given to the lamp, a filament glows and produces light. The halogen, in addition to inert gas, causes the evaporated tungsten to resettle back on the filament during cooling. That's why lamp can be operated at high temperature. It provides high intensity of light. This is an halogen lamp. The advantage of halogen lamp is that it is smaller in size. It does not need any blast. Good colors can be obtained. Excellent optical control, gives same output throughout life. It has longer life. The disadvantage of halogen lamp is during maintenance the handling of lamp is difficult. Radiant heat is more which heats the surroundings. Operating temperature is high which affects its life. CFL compact fluorescent lamp are becoming more and more popular nowadays because of their low power consumption, low running cost, longer life, attractive look, smooth light, and low maintenance. These lamps are available in different sizes and designs. These having a single rod, double rod, triple rod, or spiral. These lamps are available in different power ratings: 5 watts, 7 watts, 9, 11, 18, and 24 to 20 volts. These are the balanced spectrum. Nowadays we are more seeing this type of compact fluorescent lamp. It is physically a low pressure mercury vapor lamp having two electrodes coated with electron emissive material placed in glass tube. The tube is coated internally with some fluorescent material in the form of powder. In the tube, one drop of mercury and argon gas will to let low pressure. If you are adding any more argon and more gas, it will becomes a high pressure, so that we are going to use only one drop only. Advantages of CFL is that low energy consumption, low maintenance costs, it starts instantly, it does not heat the surroundings, excellent color properties, low operating cost, and more life. Applications: the concept compact size, longer life, low running and maintenance cost, instant glows make these lamps suitable for all places where uniform illumination is required. It is used in offices, shops, hotels, hospitals, cinema halls, residence buildings, etc. Measurement of candle power. The candle power of source in any given direction is measured by comparing it with a standard or substandard source with the help of an optimal instrument called photometer. A photometer are mostly based on inverse square law of illumination and may be classified as stationary and portable photometers. The stationary photometers are usually installed in a dark room with a dead black walls and a ceiling in order to eliminate error due to reflected light. The portable photometers are direct reading instruments used to measure illumination in houses, offices, commercials and industrial places. These are the photometer. Lightning schemes. We are having different lightning schemes: direct lightning, indirect lightning, semi-direct and semi-indirect and general lightning. In direct lightning, where the lightning we are getting 90 to 95% directly falls on the surface, that particular lightning we call it as a direct lightning. Directly wherever you want to focus at that particular surface only you can place that light, that we call it as a direct lightning. Indirect lightning is nothing but in this system the light does not directly falls on the surface, but more than 90% of light is directed upwards by using diffusing reflectors. Here the ceiling acts as a source of light and this light is uniformly distributed over the surface and glare is reduced to minimum. It produces shadowless illumination which is useful for drawing offices and composing rooms. It is also used for decoration purposes in cinema halls and hotels. This is an indirect lightning. We are not directly falling that lightning on the direct surface. Semi-direct. This is also an efficient system of lighting and chances of glare are also reduced. Here transparent type shadows are used through which about 60% of light is directed downward and 40% is directly upward. This also provides an uniform distribution of light and best suited for room with high ceilings. See here, whenever you are having high ceilings, this is a semi-direct lightning. General lightning. This system employs such type of luminaries, shades and reflectors which gives equal illumination in all directions. Design of indoor lighting sim. It should be it should provide adequate illumination. It should provide uniform distribution. It should avoid glare. It should provide light suitable colors. These are the designs. Factors required for lightning schemes: illumination level, quality of light, coefficient of utilization, depreciation factor, space site ratio. Illumination level is nothing but this is a most vital factor in deciding the number and wattage of the luminaries so that we are able to see and recognize the object properly. Colors of the body have the property of reflecting the light in different proportions. Degree of the illumination is distance from the viewer, contrast between the object to be seen and its surrounding. This is the illumination level. Type of work. Recommended illumination. If you are using an offices, you require 100 to 400 lumens per, per meter square. If it is in a schools, 250 to 400 lumens per meter square. If it is an industry, then you need to use 1000 lumens per meter square. In shops, 250 to 500 lumens per meter square. Hotels, 80 to 100 lumens per meter square. Hospitals, 250 to 3500 lumens per meter square you need to use. Quality of light. This means that the illumination should not be harmful to the viewers. It should be glare free, shadowless and contrast free. Direct glare from the source of light is most common factor. Presence of polished and glossy surface will cause indirect glare Unless diffused light is used, hard and long shadows can be avoided by using a large number of lamps and adjusting the mounting height. Coefficient of utilization factor will be equal to the lumens reaching at working place total lumens emitted by the source. Usually it varies from 0.5 to 0.8. Depreciation factor, the depreciation factor will be varies from 1.3 to 1.6. Space height ratio, it must be on a 1 to 1.5. Right, thank you.